In this experiment, we are going to create solutions of standard molarity. A solution is the mixture of a solute and a solvent. We can make solutions of different concentrations. In this experiment, we make 4 different solutions with molarities 0.5, 0.2, 0.1, 0.05. Concentration, in other words, molarity, is defined as the number of moles of solute divided by the liters of solution. First solution that we make, which is our 0.5 mole solution, is made by mixing solid copper sulfate pentahydrate with water. And then we use serial dilution to make the rest of the samples. We are moving on to create the second solution with molarity 0.2. We can repeat the same steps that we followed to make the first solution here, but we have a much easier method that we can use. This is called serial dilution. In this, we use this equation. M1 into V1 equals M2 into V2. This is called the dilution equation. We want 20 milliliters of our second solution. Therefore, we have to determine how much of volume we should take from the first solution to dilute it with water to make our second solution. In order to get 20 milliliters of 0.2 mole solution, we must take 8 milliliters from our 0.5 mole solution. Remember that our final volume should always be 20 milliliters because that's what we used in the calculations. Therefore, we have to dilute this 8 milliliters with 12 milliliters of water to make a final solution of 20 milliliters with 0.2 molarity. The same equation can be used to make our next two solutions as well. By substituting the values, I have determined the volumes that we should take from the concentrated solution to create the diluted solutions. Remember that the final volume of the diluted solution should always be 20 milliliters because that is what we have used in our calculations. Therefore, you have to add water to make up 20 milliliters each time. That means if you take 8 milliliters from the concentrated solution, you have to mix it with 12 milliliters of water to make up 20 milliliters of the solution. Similarly, if you take 10 milliliters from the concentrated solution, you have to mix it with 10 milliliters of water to make 20 milliliters of the solution. Light can interact with objects in three ways. An object appears to be a certain color if it absorbs its complementary color. In our case, our copper sulfate solution is pale blue. It will have the greatest absorbance in the orange range because orange is the complementary color of blue. For copper solutions, the greatest absorbance is obtained at the wavelength of 600 nanometers, which is the wavelength of orange color. Transmittance depends on the concentration of the solution. Transparent solutions transmit more, whereas others transmit less. This relationship is described by Beer-Lambert's law. Absorbance is directly proportional to the concentration. If you plot absorbance against concentration, it will look like this. So in this experiment, we vary the concentration and measure different absorbance values and plot this graph. So after that, we measure the absorbance of a solution with unknown concentration and try to measure the concentration of that unknown solution. So this is what we'll be doing in this experiment, and we'll see how we do that.
Okay, so in this experiment, we are going to use spectrum photometer to measure the transmittance of each sample. So first thing is we need to use the left knob to start up the spectrum photometer and let it warm up for 15 minutes. So this is already warmed up. And then if you can see the reading here, we need to adjust the wavelength to 600. Okay. So first sample we need to do is the blank sample with the DI water. So we put the sample in the spectrum photometer. So note that here is a mark. This should align with the vertical line you draw on the test tube. Okay. And then you close the cap and you get the reading. So for the DI water, the transmittance should be 100%. So we use the right knob to adjust the reading to 100. So once the reading is 100, that means the spectrum photometer is calibrated. Then we can take the blank sample out and put in our first sample. This is the standard solution 1, okay, S1. Again, the marker should align with the vertical line. And we close the cap. And then we have the reading. So we only read the top part, and that is the transmittance in percentage. So this one we get the reading about 40.9. So note you should have the correct significant number here. Okay. Then we are going to do the rest of all the other sample here. So we do them one by one, and we get the result of all these samples.